Hey everyone, welcome to today's GFG problem of the day. Hope you are doing well. So let's say today's problem, divisibility tree. So what the problem is saying is we'll be given a tree with n nodes and edge connection between them. The tree is rooted at node 1. The task is to remove minimum number of edges from the given tree such that the tree converts into disjoint union tree so that nodes of connected component left is divisible by 2. Okay, so we'll be given a tree, okay, with n nodes, and our task is to remove the minimum number of edges from this tree such that after removing the edges, whatever components are left, okay, whatever components are left, the node count in those components should be divisible by, for example, if we remove these two edges, right? So what will be, so there will be three components. One will be this, what we just marked, then one will be this, and another will be this. Okay, okay. And the node count in each component, it is, for example, here it is 4, here it is 4, here it is 2, right? And all the node counts are divisible by 2. Okay. So let's take another example quickly. We have another tree, 2, 3, and 4. Okay. So here, if you see, if we remove this particular edge, then the node, there will be two components, and in each component, the node count is 2, which is divisible by 2. Okay, so the solution is possible by removing this particular edge. So we have to remove, we have to return the minimum number of edges removed. For example, in this case, the answer is going to be 1. In this case, the answer is going to be 2, as we remove two number of edges, right? So this is a problem. Okay, now there's some pattern. For example, let me draw this again. So there's some pattern. If you look, so if the subtree count, for example, if the nodes in the subtree count, if it is even, if for example here, what is our node count here? In the subtree of 1, okay, here it is 2, right? So we can remove this particular edge. Okay, here in this case, let's see in this particular tree, right? The subtree count in this particular subtree, right? It is 2. So we can remove this edge, right? Here, here the subtree count, the node count in the subtree, it is the nodes in the subtree it is 4, which is again even. So we can remove this edge. So here, if you see, here in this case, so there were two subtrees and whose node count was even. So we removed two edges, right? So that was the answer. Here, the the nodes in the subtree count here it is what? It is 3, right? So we cannot remove this particular edge. Okay. So this is the problem, or this is the intuition behind solving the problem. Okay. Now, how we are going to solve this problem? So what we're going to do is we are going to do the DFS traversal of the tree. Okay, and what we're going to do, for example, here we're going to start with this. We're going to go to this particular node, right? We're going to do the DFS traversal. We will come to this node again. In this particular node, there are no children. So what we're going to do, we are going to return the count, okay, of this particular node. What is the count? It is 1, right? So here we're going to check if it is odd or even. It is still odd, so we won't do anything. Will increment the count and send to 1, right? So what the count will be? It is going to be 2. 1 for this and 1 for this particular node. So here in this node, we're going to check, okay, what is the node count in the subtree? It is 2, right? So we're going to increment the answer, right? We're going to increment the answer. Okay. So in this way, we're going to go. So here, when we traverse the right subtree, definitely it is 1, which is odd. So the answer will be 1. Okay. The answer is going to be 1. Okay. So let's do the code now. Okay. Before going to the code, I'll request you to subscribe to my channel if you got the intuition. I'm going to implement the Java code followed by C++. Okay. So let's quickly, so we'll be given edges, right? So the first thing what we want to do is we want to have adjacency list. Okay. Why less than equal to n? Because the root is starting at 1 and not 0, right? So what we will add this. Now what we're going to do, we're going to traverse through the edges. What we're going to do now, we are going to get the array list of, right, the array list of a particular node, right, whatever is in edge of 0, right, and we are going to add an edge, right, this in 1. Similarly, as it is undirected graph, you have to do the vice versa as well. So did that, right? So our adjacency list is now ready. So what we're going to do, we're going to right, we're going to pass the root node, which is going to start at 1, right? And then what we also going to have one boolean variable, one boolean visited array, right, to keep track of the visited nodes. Boolean n plus 1 again, as it is starting with node 1, the root, right? That is n plus 1. So we're going to pass visited and adjacency list as well. Okay. So here, now we are going to follow standard DFS practice. What we're going to do, we're going to mark this particular node as visited. Okay. Now what we're going to do, we are going to have few variables for keeping track of the node count. of the subtree, right? So CMT count till current node equal to 0. So now what we're going to do, we are going to iterate the neighbors, right, of or the children of the node, right? Get V. So we are going to check if it is not visited, the neighbor or children, if it is of the child. If it is not visited, then only process. So what we're going to do, then only run the DFS again. So what we're going to do, count till current node or node count in subtree, maybe we can say, right? Okay. So node count in subtree, we are going to run DFS, sorry, we're going to run DFS on the child node again, right? DFS equal U, right? The child node and visited and adjacent list. Okay. So what we're doing here is, right? We came to this child node, right? It is not visited. So we are now running, DFS on this particular node. We are now passing 2 to the DFS function. Okay. So similarly, we'll keep on going till till the node does not have any child, right? And then it is going to return. So the count, right? So how it is going to return, for example, here, what we'll check first, if this node count in subtree, if it is even, right? So what we're going to do, we're going to check, right? If it is divisible by 2, then we'll have one global answer variable in answer equal to 0. If we are going to increment our answer, that is, we can remove this particular text, right? So here we are checking, right? So here, if we what this 2 will return, it will return the count 2, right? One for this node and one for this particular node. So here we are checking if it is divisible by 2, we are going to increment the answer, right? That's what we are doing here. Okay. Else, right? If it is odd, right? So simply what we're going to do, we're going to increment the count of the subtree, right? And we are going to return whatever subtree we are assigning it to count, right? It need not be plus equal to, it can be this. And then simply what we're going to do, we are also going to add the current node, right? The current node count plus 1, right? And we are going to return. Okay. So this is it. This is a solution. Let me now compile it. Okay, it is giving answer as 3. Okay, so there was some small error here. Definitely, it is will require this plus, right? Because, right. So if we going to iterate, right, through other child nodes, right? So we want to have the count of the subtree, the node count of the subtree in this count as well. That is why plus equal to. So now let me compile again. Yes. Okay, the solution seems to be accepted. Thanks for watching. I would request you to subscribe to my channel. I hope you got the solution. Let me quickly walk you through the C++ code as well. So here it is, the C++ code. Here we are creating the adjacency list. Okay, that is vector of vector. And then we are pushing the edges, right, into the adjacency list. Okay, and then we are having this visited Boolean array. And then we are having this DFS. Okay, so here what we're doing standard, we are marking the node as visited. Then we are having these two variables to keep track of the node count in the subtree. Here we are visiting the iterating through the children of the node, right? And if it is unvisited, then only we run the DFS on the child, right? And here we are checking if the node count in the subtree, if it is divisible by 2, then increment the answer. Else, otherwise, whatever it is, right? Whatever the subtree returns, add this in the count variable and then return count plus 1. That is the current node as well. Okay, so this is the solution. I hope you've got the solution. I would request you to subscribe to my channel. Thanks for watching. Have a happy, healthy, and a great day. Thank you so much.